Hello everyone, welcome back. So in this video we are going to understand the problem number 2976. It's a minimum cost to convert string 1, right? So the problem is very simple, but the main thing is that it look like a string problem, but it is really hard, right? But why it is really hard, so we have to understand. This is not related to a graph problem, or this is not a greedy fill problem, right? But this is really a conceptual based questions that we should understand. If you're really confused by this problem, so don't worry, this problem tricks almost tricks everybody almost. Okay, so in this video I will explain this problem in very simple terms. So very first, why this is secretly a graph problem, right? And how the Floyd Warshall solved it in very clean way, right? So by the end of this video you will be able to solve it in very confident way as in the interview. Okay, so let's try to understand. Very first, the question saying that you pause this video, go through the statement, so you will understand. Okay, I'll show you the example and then I will explain. The thing is that it's very simple because we have given two things, string we have given, and the string, two strings we have given, that is source and target. Okay, so some of the characters are allowed in the conversion with some cost, right? So as you can see, we have given original and then we have given a change. Let me zoom out so you will understand. Okay, so as you can see, we have given the original string we have given and the target we have given, right? And some characters we have given, and if it is changed, the respectively we have the what you call the cost, right? So each rule says that you can convert character A to B by paying X. Okay, so what is our goal? Our goal is to convert this string. We have to convert this string, and from source to target we have to convert, right? Means this is what we have given, it will be get converted into this, right? So we have to convert the character by character with some minimum cost, right? So the important rule is this, that you can apply multiple conversions in a sequence, right? And you must convert each index. If any character can't be converted, we have to return -1. How? So we have to return the minimum cost to convert the string from source to the target using any number of operations. If it is impossible, convert this string into -1, right? You have to return -1, right? No need to convert because you are not able to convert, right? So if any character can't be converted, return -1. Let's take this example again. So we have ABC, target is this ABC. Okay, so if we convert, let me show you how. Okay, so think that give me 1 second. Think like we have given source, right? We have given this source and we have this target, right? So if we have source, right, and this source is like this, we have given A, B, C, D, right? So if we'll convert A into B, cost goes to 1. If we convert from B to C, right, it cost 1. C to D cost 1, right? If D to E, it cost 1, like this. Means a very simple example that we have given in the source. If each character will convert, so respectively it get the cost, right? So this is what the conversion rule is, that if we convert from A to B, B to C, C to D, D to E, like this, so we have the cost is 1. Now we compare index by index. Let's call this index 0, 1, 2, 3, right? So for each index we have converted from, let's call the source at I, and this is called target at I. You can say target at I, like this, just for example. Okay, source at I are, these are the characters we have given, and target at I is, these are the characters we have given. Okay, so if you'll say the total cost is nothing but 41114, right? So far this looks easy, right? But now comes the twist. What is the twist is there? What if the rule exists? Let's suppose that if the rule exists and it is saying Let's take like A to C, you can say, right? And how many, let's take a cost is 10. Let's think that cost is 10, right? But also, if the rule says that we have A to C and the rule exists here, right? Rule exists. This is, and but also we have another rule, right? That we can convert A to B in cost 1, then B to C we can convert into 1. Okay, so should you pay this $10 or 10 rupees, right? Whatever you want to take the conversion. If you converting from A to C is 10 units, and if you're taking from A to B, B to C, it costs you 2. So do you want to pay 10 or 2, right? You should not pay 10, right? You can pay 2, right? No, right? We will pay this one. So you should go with this minimum cost. This is why this is not a greedy problem, guys, right? This is where the most people get stuck, and you will think that this is something else, right? But why is this problem is a graph problem, right? That we should understand. Think that think of each character is a node, right? Let's call how we can take, let's suppose we have very first take A. From A to B if you are taking, so A is a character, B is a character, so each character think like as a node, and from A to B it costs 1, from B to C it costs 1, C to D it costs 1, D to E it costs 1, right? So each character is a directed weighted graph, right? Not graph, is, we can say, is directed weighted is, right? Now the question becomes, what is the minimum cost from the call that we have seen, source at I to target at I, right? What is the minimum cost? And you must answer for that for every index that we have seen, right? From 0 to 1 we have gone like that, right? 3. So this is the shortest path problem, right? This is the, because we need to find the minimum cost path, correct? If you want to find the minimum path cost, right? So this is the shortest path problem. And if you're trying with the Dixetra, so Dixetra will go for every character and it will try to do the in a way where we have to compare each character, right? But there is another concept that if you go with Floyd Warshall, right? So this is a algorithm. This is a perfect way where the Floyd Warshall is a perfect example or perfect way of making this type of problem as a solution. Why? Very first, if you see that there is a 26 lowercase character, and we want the shortest path between all pairs, and this is exactly what the Floyd Warshall algorithm does. It handles indirect paths and it simplifies the implementation, and it is fast for 26 nodes, right? The very first is that if we can define the problem, let's call the solution way, right? The very first I will say you need to build a cost matrix, you can say, right? Where you need to do cost, you will take U and V, okay, and you will say, okay, the minimum cost to convert from U to V, and then you need to initialize this called, let's suppose, cost for I and I for the same node, right? You will initialize as 0, because if you remember, for a node for itself it's a 0 value, right? So you have to apply like this, and in other case, let's call for others node, you can take for to initialize as an infinity, okay? In the step 2, let me clean here. In step 2, what you need to do, you will apply the Floyd Warshall, right? And you will try every character as a middle node, right? So for every character you will try as a middle node. Let's call each k, we can say that, and for each k is nothing but each I will go, then for each I will go, each j will go, each j will go, right, like this. And then you will find the cost, and you can say I and j. But to find this I and j, what you need to do is you have to find as a minimum. We'll say the mean between two things, a and b. What is this a and b? I'll show you. So let's call that you want to find the cost at I and j, and I said the minimum, right? Minimum between what? You have to find the minimum between, call the cost at I and j. And another thing, this is a, and another thing become what? The cost at I to k, and there will be plus, right? So to do plus, you will say cost at k to j. Okay, understand? This is a, this is your a part, and this is your b part. Okay, so now we know that the cheapest conversion, right, means we have tried for each middle node. So for each middle node is known as k, and then we have tried for each I, and for each j, right? We will find like this, we will apply the Floyd Warshall, and we'll try every character as a middle node, and we'll try to find like this the cost, right? So now we know the cheapest conversion between any two letters we can find like this. So in the step 3, you just need to calculate answer. How you will find the calculate the answer? I'll show you. So in step 3, we will loop over the string, and if the character matches, right, we'll say the cost is nothing but 0, right? The very first term. Then we should say if the string conversion or character conversion is impossible, right, you know that you have to set -1. You have to return actually -1. In step in third point, if these two if is not working, it means we will come to the else condition, and we'll say else means the character conversion happen, and we need to add the pre-computed cost to the answer, and this is what we are going to do. So I'll show you how I have developed the code, so it will be easy for you to understand. So as we will go, let me zoom out a little bit. Okay, so very first, as I told you, these things we have given, right guys? Oh sorry, we have given. So very first you will define infinity, right, and then you will take the this matrix. You can take you will take the matrix of 20 to 26 into 26 matrix, and then you will compute. You will initialize if it is equal to, you will initialize 0, otherwise infinity, as I told you. Then you will do the direct conversion, string conversion. So very first, you know the character, right? You have u and v, and you will find the minimum cost. What is the minimum cost that you have, right? So you can define the minimum cost from the direct conversion, and then you will use a Floyd Warshall, right? From the Floyd Warshall, you will pre-compute the you will find the cheapest conversion between any two nodes. You will have the data. Now it's time to find the answer, right? How will find? You know that if the character matches, it will directly goes to the, it will not go to these conditions, right? So if the conversion not possible, you will return -1. If the character matches, you will keep adding all the values 0 here in the answer, right? Because this value will be 0 itself. And if anything is having, right, let's suppose the conversion, we have direct conversion, we have calculated already, so the pre-computed value will keep adding onto the answer, and finally will return the answer. So in the source or target, if both are having the same, it means all the value will go to the 0, and you will return as a answer 0. In other cases, you have the pre-computed value, and you will keep adding on the answer, you will return the answer. Okay, so this is what we have, guys. So I have shown you, like, very first what I have done. So for the implementation purpose, right, we have defined 26 into 26 matrix, right, and then we have done initialization. So we can see the infinity initialization in case of it is we have to initialize in the Floyd Warshall, right. We have used the loops as we have discussed, and then we have calculated. So the very common mistake that people used to do is to use the greedy algorithm, and they are running into this etc for every character and forgetting indirect conversion, right. So you should understand that this is not only the direct conversion thing, it is an indirect conversion thing, and you have to use the algorithm like this, right. And so it will handle the impossible cases also. If you're trying with the simple thing, it will not handle the possible cases. So this is not a string problem, guys. It's a graph problem, shortest path problem on the character. It will also work with the etc, but the complexity will be more, right. So I'll suggest you can write the time and space complexity in this video. In case if you are struggling with DSA, you can join our online classes, and for that you need to ping me in the WhatsApp. And that's all I have in this video. Thank you for watching this video. I'll see you in the next one. Bye bye.